The metallic screech of bending steel didn't sound like a failure at first. It sounded like a building clearing its throat. A long, ugly groan was buried under music, applause, and the soft clink of glasses. People smiled through it. They kept filming. Nobody wants to be the one who panics at a grand opening. Then the noise stopped, and in that tiny silence, you could hear the place breathing wrong. In the lobby, down near the base of the main support column, a crack showed up like a thin black vein. Not wide, not dramatic, just enough to make every engineer in the room go cold. Because concrete doesn't crack in the middle of a celebration unless it's already been losing a fight for a long time. The air smelled like new paint and fresh stone, but under it there was another smell. Dust. A dry, chalky bite that shouldn't be there on day one. You don't notice it if you've never been around stressed concrete. If you have, it hits you like a warning flare. A few people drifted closer, curious. They stared like it was a weird stain. Someone laughed. Someone said the building was settling. That word gets used like a blanket. Toss it over a problem and hope nobody looks underneath. But here's the thing. Settling is slow. Settling is a quiet math problem. This was a loud one. The crack climbed, millimeter by millimeter. Not fast enough for a stampede, just fast enough that a sharp-eyed worker stepped back and whispered, "That wasn't there." And now we're standing in the wreckage later, trying to answer the only question that matters. How did this even happen in a building that was supposed to be luxury? Because the ghost detail is still out there, in plain sight. A high-end apartment block that looks perfect in photos. Glossy ads, clean lines, big windows, and it sits completely empty because it leans 3 inches to the left. 3 inches doesn't sound like much until you stand at the bottom and look up. Your eyes don't lie. The whole thing feels like it's slowly trying to fall over without making a scene. That's not a haunted house. That's an engineering mistake you can measure. And when you pull on the thread, you don't just find one bad decision. You find a chain. Blueprint error. Subsoil stability is ignored. A foundation failure that didn't happen in one dramatic moment, but in hundreds of quiet moments where people chose speed, money, and optics over reality. It starts with paper, not the concrete, not the steel, the paper. In the final drawings, the architect used the wrong units. That sounds small, harmless, like a typo, like something the software would catch, like something a whole team would never let through. But that's exactly how disasters begin, not with a villain, with someone tired, someone rushed, someone certain they're right, someone copying a detail from an older file and not noticing that the numbers are speaking a different language now. It's one of the oldest traps in engineering. Inches pretending to be millimeters. Feet dressed up like meters. A clean line on a blueprint that's actually a lie. And the lie doesn't show up on the screen. It shows up months later when you pour real weight onto real ground. The job moved fast. Too fast. The developer wanted an opening date locked to marketing and sales. The building wasn't just a structure. It was a product launch. That changes everything. When the calendar becomes the boss, physics gets treated like a complaint. So people did what they always do under pressure. They trusted the drawings. They trusted the chain of approvals. They assumed somebody else had already checked the numbers. And out on site, crews built exactly what they were told to build. The foundation design looked normal at a glance, clean, efficient, but it was tuned to the wrong scale. Depths, spacing, load assumptions, little values that don't scream when they're wrong. They whisper. They hide inside tidy diagrams and confident signatures. The soil under the site wasn't stable the way the brochure implied. The tests were there. They always are. A stack of reports, graphs, core samples, terms that sound official enough to stop questions. But subsoil stability isn't a vibe. It's not probably fine. It's either bearing the load the way you expect, or it's waiting for the right moment to punish you. This site had layers, fill material, soft pockets, a history that the surface didn't advertise. The kind of ground that can hold for a while, then shift when water moves, when vibrations build, when the load path concentrates where it shouldn't. You can build on difficult soil. Engineers do it all the time, but you don't do it by pretending the soil is something else. And that's where the blueprint error stops being a clerical mistake and starts becoming a mechanical setup for failure. Because a foundation doesn't fail like a light bulb. It fails like a slow betrayal. It settles unevenly. It tilts. It creates stress where you were never designed for stress. Columns that should be purely compressed start to bend. Concrete that should be calm starts cracking like it's trying to speak. At first, the building can hide it. Drywall covers tiny shifts. Decorative panels mask early fractures. The elevators still run. The doors still close. People walk through the lobby and feel nothing except pride. But the structure feels it. You can see it later in the inspection photos. Hairline cracks around beam column joints. Microfractures that look cosmetic until you map them and realize they're forming a pattern. A pattern is the building telling you, my load isn't going where you think it's going. And the scariest part is how normal it all looked in real time. Because the people on the ground weren't thinking about unit conversion. They were thinking about schedules, deliveries, inspections, curing time, and whether the pump truck would arrive before the rain. The people signing off were thinking about checklists and liability, and how to keep the project moving. Nobody wakes up and says, today I'm going to build a leaning luxury tower. They wake up and say, we're behind. In the weeks before a grand opening, a building goes through this strange phase where it's finished enough to look perfect, but not finished enough to be honest. The lobby lights are on, the marble is polished, the brochures are printed. People walk through with hard hats off, talking about views and amenities like gravity is a solved problem. And behind the scenes, the structure is doing math every second. Not the clean math from the drawings, real math, weight, moisture, temperature swings, vibration from nearby traffic, the tiny bounce of construction loads rolling across fresh slabs. All of it pushes on the foundation. All of it asks the subsoil the same question again and again. Hold. If the ground is solid and the foundation is right, the answer stays the same. If it isn't, the answer changes slowly, then suddenly. That's why the earliest warnings are often boring. You don't see foundation failure. You see symptoms. A door that rubs only on humid days. A window that suddenly needs force. A floor tile that pops loose and gets replaced like it's cosmetic. A hairline crack in a corner that gets blamed on shrinkage. Each one is a vote to ignore, a vote to delay, a vote to keep selling the dream. Because this wasn't just a building, it was inventory, units, revenue, investor confidence, a luxury launch with a price tag attached to every day on the calendar. And when money gets involved, failure gets managed like a PR problem instead of an engineering problem. Not, is this crack structural? But, do we have to call it structural? Not, is the foundation moving? But, can we monitor it quietly? Monitoring becomes a ritual, a clipboard, a few photos. Someone draws a line with a marker and writes a date next to it. Someone else takes a measurement and shrugs because it hasn't changed enough. Enough for what? Enough to scare the right person? Enough to stop the opening? So the building keeps talking, just not loudly enough for the public to hear yet. Then comes the grand opening. The building is full of new loads it didn't have during construction. People, furniture, equipment running, HVAC cycling hard, water in lines, and most of all, vibration. Footsteps, doors slamming, elevators running non-stop, music in the lobby. Nothing dramatic, just enough to nudge a stressed system right up to its limit. That's the pivot point you can almost see in slow motion. A column under axial load starts to take a small bend because the foundation under it isn't level anymore. The concrete on the tension side starts to micro-crack. The rebar takes tension like it's supposed to. But if the detailing, cover, or placement is even slightly off because the drawings were wrong and the field followed them faithfully, the margin is thinner than anyone thinks. The crack becomes visible. Not because it just started, but because it crossed the line where invisible damage becomes visible evidence. And when the first crack showed itself in that lobby, it did it like a whisper turning into a voice. A thin line, then a small branching. A faint pop you feel more than hear. The kind of sound that makes your stomach tense because your body knows it before your brain does. People step back, phones lower. Someone says, "Is that normal?" And now the building has witnesses. Now the building has to perform because it can't hide anymore. That's the moment every construction disaster quietly circles. Not the start of the project, not the budget fights. The moment the system fails in public and the humans have to choose what they value more, honesty or momentum, because the cost of doing the right thing is immediate and visible. The cost of doing the wrong thing is delayed and might become someone else's problem. And that's why that empty luxury building still sits there leaning 3 inches to the left. Not because nobody knew, but because enough people kept choosing later. The crack in that lobby is the kind of warning you can still argue with. People will say it's cosmetic. They'll say, concrete does that. They'll say the building is new, it's stretching its legs. But there's another kind of warning that's harder to deny. It's when the structure tells you, straight up, that it's already failing, and the system decides to keep going anyway. In Miami, 2018, there was a brand new pedestrian bridge outside Florida International University. Fresh concrete, clean lines, the kind of project that's supposed to scream progress. And then, before it even opened for foot traffic the way people expected, it gave off the same kind of message your body recognizes before your brain does. Cracks, big ones, not hairline, not paint will cover it. These were cracks that showed up in a critical zone and didn't look like shrinkage. They looked like stress choosing a path. People saw them. Engineers discussed them. Meetings happened. It wasn't a secret, and that's what makes it terrifying. Because the bridge didn't fail in the dark. It failed in daylight, with warning signs on the table. If you ever want to understand how human error becomes mechanical failure, it's right there in that sequence. A structure starts talking, the people in charge hear it, and the machine of deadlines and pride keeps rolling. That day, traffic still moved underneath. Cars, trucks, normal life. And above that road, the bridge sat there like a loaded spring. Concrete under compression is calm. Concrete under the wrong kind of load starts to feel brittle, like it's holding its breath. The sound people describe around failures like this isn't always a big boom at first. Sometimes it's a sharp pop, a deep crack, a weird grind. Then the air fills with dust so fast it looks like smoke, and your ears ring because the collapse isn't just loud, it's pressure. The kind of pressure that punches you in the chest for a half second and makes everyone nearby freeze like their instincts hit the brakes. There's a moment in every collapse that's almost unfair. A fraction of time where the structure hesitates, where gravity is already committed, but your eyes haven't accepted it yet. Then, it goes. A bridge doesn't fall like in movies. It doesn't neatly fold. It drops heavy. It shatters. It slams the road like the ground just got hit by something alive and angry. And the dust that comes off concrete isn't like dirt. It's finer. It hangs in the air. It sticks to sweat. It turns your mouth dry instantly. People cough without choosing to, and after, you always see the same thing in the footage. Cars crushed into shapes that don't look real. Workers running with that stiff, panicked posture. A cloud drifting over the street while everyone tries to understand what the math just did. The technical side matters, but what matters more is the decision point before it happened. Because cracking is the bridge telling you, my load is not going where you think it's going. But the world doesn't run on engineering instincts. It runs on momentum. People wanted it done. People wanted it open. People wanted to believe the project was still under control. So they kept talking about fixes and adjustments, like the structure was a negotiation. And the bridge didn't care. A structure doesn't care how much you've spent. It doesn't care who's embarrassed. It doesn't care what the press release says. It only cares whether the forces make sense. When those forces don't make sense, concrete stops pretending. And you can feel the pattern between these disasters once you see it. A blueprint can be wrong by units and still look normal. A foundation can be wrong by inches and still pass through close enough. A bridge can crack in public and still get treated like it's manageable. And every time, the danger isn't only the material. It's the pause after the warning, when someone with authority chooses the cheapest interpretation. That's the human error part nobody likes to own. Because it doesn't sound like sabotage, it sounds like optimism. We can handle it. We'll monitor it. We're almost done. And then the pivot point hits, and all that optimism becomes evidence. Now, if you want a collapse that smells like pure schedule pressure mixed with negligence, you don't even have to stay in Florida. Go to New Orleans, October 12th, 2019. A high-rise going up downtown, the Hard Rock Hotel project, tall enough to feel permanent. new steel, new concrete, a crane sitting above it like a mechanical spine. Then the building partially collapses mid-construction. Multiple floors come down. The site becomes a jagged mess that looks like somebody tore a chunk out of the skyline with their hands. This one doesn't feel like one thing broke. It feels like a chain letting go, link by link. Steel isn't supposed to surprise you. It's supposed to give you warning through bending, through deformation, through visible distress. But when a frame loses the integrity of its connections, the warning can be nothing more than a sound. A sharp metallic snap, a tearing scream like sheet metal ripping but deeper. Then the ground shakes with that sickening heavy rhythm of sections dropping and hammering what's beneath them. Dust doesn't rise. It blasts outward. Concrete powder and hot machinery smell mix in the air. And in the footage, the city looks stunned, like it's watching the laws of physics break a promise. Later, the details that emerge are the type that leave engineers staring at each other in stunned silence. Bolt connections. It may sound insignificant, but that is the kind of thing that seems too small to cause harm until you remember what steel truly is. A steel building is not just steel beams floating in space. It is a system, a chain, a series of promises at every joint that say, when load comes here, I will carry it and pass it on. If one joint fails, the load does not vanish. It moves on, searching for the next weakest point. So when people talk about a collapse, picture it accurately. It is not a single event. It is a redistribution, a sudden shift in demand. A frame that was stable at 9:59 becomes unstable at 10 Huntuk because one connection exceeded its limit and dragged the rest down with it. The reason Miami and New Orleans share a link with the leaning luxury tower is because they reflect the same human behavior. Warnings are given. Margins are treated as optional. And when the system fails, everyone acts like it came out of nowhere. But it did not. And the next failure is worse, because it is not a hidden error or a crack that sparked debate. It is a change made intentionally, approved, and quietly turned into the deadliest form of surprise. Kansas City, 1981. A hotel atrium with suspended walkways, full of people, music, movement, a typical night. Then, above them, a small decision becomes deadly. A design tweak in the hangar connection, something you could explain as in a sentence, redistributes loads in a way that doubles the pressure on a critical component. It looks good on paper, but in reality it creates a hidden overload waiting for a crowded moment. The tipping point is not dramatic at first. It is the instant when the metal reaches its breaking point. There is no warning, just a sharp snap that cuts through the room like a gunshot made of steel. Then a grinding scream as the connection breaks, and the walkway crashes down. The warnings showed up the way they always do when a structure is being forced to lie. Cracks that do not match cosmetic shrinkage. Vibrations you feel in the floor more than you hear. A building that starts talking through its finishes. And the dangerous part is the human reaction delay, dismiss, keep the doors open a little longer because closing costs money now, and collapse costs money later. When the pivot point arrives in these failures, it is never polite. It is that split second where the system's last margin disappears. One critical area gives loads jump to places already near their limit, and the structure stops behaving like a building, and starts behaving like falling mass. You don't need a cinematic setup to understand it. You just need the sound. Concrete cracking like a thick branch under your boot, multiplied by an entire floor. Then dust, so fast it feels like the air itself turned solid for a moment. Now stitch these failures back to the first one. The leaning luxury tower with the wrong units, the wrong assumptions, the subsoil that didn't forgive, the foundation that settled uneven and turned a clean column into a warning siren. Different structures, same pattern, tiny choices, quiet compromises, a checklist mentality that treats physics like it's negotiable, pressure that turns stop into monitor, people trusting familiarity more than they trust evidence. And if you want the ending to feel honest, you return to the first sound. That metallic screech wasn't the building being dramatic, it was the structure translating a chain of decisions into sensation. Wrong units in a final drawing. Ground that wasn't as stable as the brochure promised. A foundation that couldn't spread load the way the math claimed. Stress rerouted into the main support until the column finally said out loud what everyone had been avoiding. The crack in the lobby wasn't a beginning. It was an announcement. And the reason these stories stay with you isn't just that things broke. It's that so many of them broke while people were still insisting they were safe. You walk into places like this every day. You trust the concrete, you trust the steel, you trust the approvals. And then you learn how thin that trust can be, when a single, overlooked detail turns into a sound you feel in your teeth. You would never have guessed it would happen this way.